second experiment, we are going to learn about earthing, types of earthing, why earthing is necessary, how we can minimize earthing resistance, then cable, its construction, its application. Next to it, we are going to see fuses, types of fuses, its application. Next to it, MCB, its construction, working principle, and then why a molded gate circuit breaker, earth leakage circuit breaker, and RCCB are used. Okay, this experiment is all about that. Now see, like this distribution board you will find at your home. This is called as, complete one is called as distribution board. Okay, so distribution board here, this one is a pole. Okay, this one is a pole beside road. You can see this pole, it supports transmission line. Transmission lines, they are used for transmission of electricity over large distance. Over pole, insulators you will find, and insulator supports transmission line. Here red one is live phase and black one is neutral. Now this energy meter, it display energy consumed by consumer in kilowatt hour. 1 kilowatt hour is equal to 1 unit. Earlier days, induction type of energy meter was used. In it, you will find rotating aluminum disc is there, and one permanent magnet and two electromagnets. Nowadays, induction type of energy meter is being replaced by digital energy meter. Digital energy meter, it has microcontroller IC. Whatever the program burn in that microcontroller IC, as per that programming, that digital energy meter work. Along with microcontroller IC, you will find electronic circuit is there, current transformer, potential transformer is there, and it display energy consumed by consumer in kilowatt hour. Now for energy meter, you will find 4 terminals are there. 2 are incoming wire, it's a single phase energy meter. So one is live phase with red color and black one is neutral. Whatever the 2 incoming wire to energy meter, same 2 wire leaving to it. Okay, energy meter, it can be single phase type or 3 phase type. Now residential area, you will find single phase energy meter is there. For our college, industries, 3 phase energy meter is there. Okay, now whatever these 2 wires leaving energy meter, these are connected through MCB. This is miniature circuit breaker. In detail, we'll see miniature circuit breaker. Next to it is RCCB is connected. RCCB, residual current circuit breaker. Its working also we'll see in detail. And then later on, from this live phase, terminals are tapped for each room or every load. In between it, you will find single pole MCB is connected. This one is double pole MCB and this one is single pole MCB. Then after this single pole MCB, this in this live phase switch is connected and that terminal is connected to load. Okay, so all of you can see here that this lamp load, one terminal of every load through switch and MCB is connected to energy meter and another terminal is connected to neutral. Like this connection of distribution board you will find. In next slide also the same thing, pole is here, energy meter, MCB and single pole MCB for each phase. Along with this, you will find here green color wire. Green color is used for earthing. Black color insulation is used for neutral. Okay, so this earthing arrangement is done under the ground. So all these are socket. All of you know socket. In socket, lower 2 terminal, one is live phase, another is neutral, and the upper one with more diameter, that is the earthing. So these are nothing but earthing terminals of socket. Okay, you can consider this, and from here earthing connection, this earthing wire is connected to ground earthing arrangement. Earthing also in detail we are going to see in today's experiment. Now, wire means, all of you know wire. Every wire, it has a centrally conductor and it is insulated with some insulating material. Earlier days, whatever the conductor at the center, it was a single solid conductor. More the diameter of that conductor, more is the possibility you bend that wire, that conductor inside the wire will break. Okay. So what is done later on? Whatever this, rather than single solid conductor, stranded conductors being used at the center of every wire. Okay, so every wire you will find, rather than single solid conductor, stranded conductors are used and they are insulated with some insulating material. Now, because of stranded conductors at the center, even if you are, whatever is the diameter of that conductor or diameter of that wire, even if you bend that wire, conductor inside it will not break, means flexibility increases. Okay, so every wire you will find centrally stranded conductors insulated with insulating material. Okay, so this is about the wire. Now we'll see the wiring arrangements. So this one is called as the clit type of wiring arrangement. You can see here wires are means that conductors carrying electricity, they are insulated with insulating material. So these wires are open. They are fixed with porcelain clits to wooden base or to wall. So as wires are open, this arrangement is not safe for permanent electricity supply. This one you can use only for temporary electricity supply, like Ganpati festival, construction going on, any function. Okay, so you can go for this clit type of wiring arrangement. Porcelain clits are used to fix the wire to wall or wooden base. It is not safe because in case of fire, it is very dangerous because wires are open. Again, they can easily catch the moisture. So it is not safe to use clit type of wiring arrangement. This one is batten type of wiring arrangement. These were used in old days. Okay, so nowadays it is also being used only for temporary power supply. Here wires also open, only they are fixed with metallic clips to the wooden base or to wall. Wooden base you are using means lots of tree cutting will be there. Wood easily catch moisture. Wires are open, so in case of fire it will be dangerous. Okay, if it catches fire. So if porcelain clits are used, then that is called as clit type of wiring arrangement. Rather than porcelain clits, if metallic clips are used to fix the wire to wooden base or wall, directly to wall, then that comes under batten type of wiring arrangement. Clit and batten type of wiring arrangement is used only for temporary power supply. Okay, nowadays you will find this one, conduct type of wiring arrangement. Two types are there, surface conduct wiring and concealed conduct wiring. Okay, so what do you mean by surface conduct and what do you mean by concealed conduct wiring? See here, surface conduct wiring means what? Whatever the RYB neutral or live phase and neutral, these wire they pass through some pipe. This pipe, it can be plastic or metal, and if like this pipe is fixed above wall surface, then that is called as surface conduct wiring. Okay, that is called as surface conduct wiring. Wherever appearance doesn't matter, you can go for surface conduct wiring. If like this arrangement, that is wires passing through some pipe and that pipe is buried under wall plaster while doing construction only, then that comes under concealed conduct wiring arrangement. Nowadays, wherever appearance matter, like residential area, commercial area, industrial area, malls, shops, so you will find concealed conduct wiring arrangement is used. Wherever appearance doesn't matter, you can go for surface conduct wiring arrangement. Okay, but once concealed conduct wiring arrangement is done, And still, if you want some connection of phase and neutral for some fan or lamp or tube light or any load, then you can go for casing caping type of wiring arrangement. So here base and cap white color porcelain material, and through that supply wires they pass RYB neutral or live phase and neutral. Okay, so like this wire above, like this arrangement, casing caping wiring arrangement above wall surface, its appearance is quite good because concealed conduct type of wiring arrangement is done while doing construction only. Everything buried under wall plaster wherever appearance matter. Once construction over, still if you want power supply, that is phase and neutral connection, so go for casing caping wiring arrangement. So this is about the wiring arrangement. Next one is earthing. Why earthing is required? So in previous experiment we have seen, if any leakage current get produced in outer metallic body, to protect the person working on it or operating it will be safe if earthing is done. Okay, what does it mean? See, motor, generator, whatever we use in electrical lab, they are not open, they are covered with outer metallic body. So you will find like this green color earthing wire, one end of that earthing wire is fixed to outer metallic body of that motor and generator. Okay. One end of that earthing wire is fixed to outer metallic body of that motor and generator, and another end of that earthing wire is connected to earthing of that building. So what occurs if inside motor and generator many windings are there, they are carrying current and they are insulated with some insulating material. If accidentally any wire breaks and its conductor is touching to outer metallic body of that motor or generator, whatever the current flowing through that outer metallic body is called as leakage current, because that current don't help in producing the output. That's why it is called as leakage current. So that leakage current, what occurs if it get produced in outer metallic body of that motor or generator, these earthing wire resistance is very less than 5 ohm. So current always prefers minimum opposition path. Even if you are going to touch to that outer metallic body of that motor or generator, our body resistance approximately 1000 ohm. From person to person it differs because weight, water content, muscle, height, everyone's different. So approximately 1000 ohm, and earthing wire resistance less than 5 ohm. So leakage current, any current always prefers minimum opposition path. So rather than your body, even if you are touching to that motor or generator outer metallic body, so this leakage current will flow through this earthing wire whose resistance is less than 5 ohm to ground. Okay, so that's why earthing is required. If this earthing connection is somewhere in open condition, suppose here it is in a breaking condition, then what will happen? You will get shock. Okay, so this earthing connection must be proper. So there are, see here, all of you can see this earthing wire from outer metallic cover is connected to ground, earthing connection. So even if leakage current is produced in outer metallic body, this person is safe. He will not get shock. Leakage current will flow through earthing wire to ground. Here earthing is not done. So if leakage current get produced in outer metallic body, whatever the person operating on it, if he touches to its outer metallic body, he will get shock. Okay, so wherever required, earthing must be done. Two types of earthing are there. One is plate type of earthing and another one is pipe type of earthing. Plate type of earthing and pipe type of earthing, what is the difference? Here plate is used of galvanized iron or copper material, and here only pipe or rod is used of same material. That is only the difference. Okay, so whatever both the diagrams you can see here, this is the ground level. all construction, whatever you can see on the screen, it is under the ground. Okay, this is the ground level. In second also, that is pipe type of rod type of earthing, this is the ground level. This all arrangement is under the ground. Okay, so what is done in plate type of earthing, pipe type of earthing? So under the ground at some particular depth, they make one pit, and in this pit they put this galvanized iron or copper plate. Round this plate in the pit you will find alternate layers of salt and charcoal they put. All of you know, more the moisture content, lesser will be the resistance. Okay, see this one connection is nothing but this is earthing wire. Okay, suppose this is the socket earthing terminal, this one. Okay, and this is phase and neutral below it. So from this earthing terminal, earthing wire is connected like this to this plate. Okay, so earthing resistance we want minimum. So for that, what you can do, how you can minimize the earthing resistance, you go on increasing this depth. More the depth, more will be the moisture content under the ground, lesser will be the earthing resistance. Okay. Beside this plate, around this plate in a pit under the ground, you can put alternate layer of salt and charcoal, because salt and charcoal, they hold moisture for longer duration. More the moisture content, lesser will be the resistance. Galvanized iron and copper is used for manufacturing of this plate, so earthing resistance will be less compared to other materials you use. Again, dimensions of this plate or this rod you have to select so that R is equals to rho L by A. Resistance is directly proportional to length and inversely proportional to cross-sectional area. So accordingly, you have to select length and cross-sectional area so that earthing resistance will be less. Here funnel is there. Okay, so through this funnel in summer season, you can pour water, so that moisture content under the ground will be more and earthing resistance will be less. For rod type of earthing also, you can find here funnel is there. Through this funnel you can pour the water. Now what you can do to minimize the earthing resistance, use galvanized iron or copper, select the dimensions of this plate or rod so that resistance will be less. Use alternate layers of salt and charcoal so that it will hold the moisture for more time duration and earthing resistance will be less. Through this funnel you can pour water to increase moisture content under the ground. Rather than using single plate, all of you know, suppose 4 ohm and 4 ohm I connect in parallel, what will be its resistance? 2 ohm. Okay, so rather than single plate, you can use number of parallel plates wherever it is not possible to increase the depth. If under the ground rocks are there, so moisture content also will be less and it becomes difficult to increase the depth. In that case, what you can do, rather than using single plate, use number of parallel plates. 4 ohm in parallel, resultant will be 2 ohm. So number of plates you go on connecting in parallel, resistance becomes less. Okay, so earthing resistance must be less. If any leakage current get produced, then through this socket earthing terminal, through earthing wire, it will flow to ground. Okay, so person operating on it will be safe. So this is about the earthing. How you can check? See, this is the socket earthing terminal. Okay, so how you can check whether the earthing connection is done proper or not? For that, what you do? This is the live phase. Okay, take one lamp. Okay, take one lamp. Suppose this is the lamp I am taking. It's one terminal you connect to live phase. It's another terminal you connect to earthing. And whatever the switch is over here, that you switch on. If this lamp glow means connection, earthing connection from this earthing terminal up to ground is continuous. It is not in a breaking condition. But even if you switch on and lamp don't glow, means this earthing connection somewhere is in a breaking condition. So like this, you can check earthing. If you find earthing is not done correctly, then inform to concern and get it repaired. So this is all about the earthing. Next one is cable. So cables, these are used for underground transmission of electricity. Wherever overhead transmission line installation not possible, like in congested area, overhead transmission line installation not possible. So in that case, you can go for cable. Even in our college, from control room till to every building, supply is given 3-phase 4-wire AC supply is given with the help of cable. This one is a construction of cable. You can see here, this is the R phase, this is Y phase, and this is B phase. Okay, so it's a 3-core cable, RYB. Whatever the cable available reaches to every building in our college from control room, that cable is 4-core RYB, and one more wire is there, that is neutral. Okay, so one more core is there, that is 4-core cable. Here whatever you can see on screen, it is only RYB 3-core cable, but whatever the cable reaches to ABCD, marine management, workshop buildings from control room, from secondary of transformer, that is 4-core cable, RYB and neutral. Okay, so centrally you will find this is the R phase conductor, this is Y phase conductor, and this is B phase conductor. So these conductors are made up of aluminum. They are not solid conductor, they are the stranded conductors. Okay, under the ground lots of space is there, so rather than copper, for cables aluminum material is used to manufacture the conductor. Okay, because aluminum if you are using, then size becomes more, but costing reduces, cost will be less compared to copper. That's why in cable aluminum is used. Now this, what is its purpose? Conductor, it carry current. Okay, AC current, because electricity we transmit in the form of 3-phase AC. Then these conductors you wanted to put under the ground, so obviously some insulation must be there. So insulation is there above these conductors, you will find, so that no short circuit will be there and conductors will be safe. Okay, now this insulation material, this is the insulation material. This insulation material also you have to protect from acids or alkalis in the soil. So metallic sheath you will find. On insulation you will find metallic sheath is there, and what it does, it protects the cable from moisture, gases and acids, alkalis in the soil. Okay, this metallic sheath is made up of aluminum or lead. Okay, so all of you can see here, first centrally it's a conductor is there, this one is conductor, above conductor insulation is there, above insulation this aluminum or lead sheath is there. Okay, so it protects insulation from acid, alkalis, moisture content in the soil. Okay, now this metallic sheath as it is made up of metal, if moisture content comes in contact with it, its corrosion will take place. And if armoring layer is there, which is also metallic, so because of it, due to friction between lead sheath and armoring, both are metallic. Okay, so due to friction, damage will be there. So what is done, one fibrous layer is there between lead sheath and armoring, that is called as bedding. Okay, so to protect the lead sheath from this armoring, what is there, bedding, fibrous material is there. And again, what is the another advantage, due to this fibrous material, moisture content will not be in contact with metallic sheet, so its corrosion will not take place. Okay, now again, to increase the mechanical strength, if you want to further increase mechanical strength of this cable, you wanted to protect that bedding layer during digging work. Okay, after few years, if digging work going on, then cable should not get damaged, its insulation. Then this bedding layer should not get damaged. To increase its mechanical strength, armoring you can provide. Again, it is a metallic layer. It is made up of galvanized steel. Okay, so to protect this armoring, again fibrous layer is there serving. Okay, so again one advantage, this armoring is metallic, so to stop its corrosion serving, if it is there, then its corrosion will not take place of armoring layer. So last two layers, not everywhere you will find armoring and serving, but previous all up to bedding you will find in every cable. Last two depending on environmental condition. So this is all about the cable. Cable, it is used for underground transmission of electricity. Wherever installation of overhead transmission lines not possible, underground cables are installed for transmission of electricity. Cable, if you are using for a transmission of electricity, then costing increases compared to transmission line, because transmission line no insulation required, it is above the ground. Even if fault occurs, then in case of transmission lines it's easy to locate. But what's about with cable? Lots of digging work required, it is time consuming process, costing, manufacturing cost of cables, their installation cost, repairing cost is very high. Again, to detect the fault under the ground, it's difficult. Okay, but so that's why when the, in which case cable are used, wherever installation of overhead transmission line not possible, then only cables are used. Okay, so this is all about the cable. Next one is fuses. Okay, so in previous lecture I told you about the fuses. In case of overload and short circuit. Okay, in case of overload and short circuit, so in previous experiment I told you, if it's a overload or short circuit, overload means load beyond capacity of any motor on it, load beyond its capacity on generator or transformer on it. So if load beyond the capacity, that is called as overload. Short circuit means what? Phase and neutral wire carrying current touches to each other, short circuit will be there. Their conductors touches to each other, short circuit will be there. Transformer primary winding, secondary winding, if its insulation get damaged and they are carrying current and touching to each other, short circuit will be there. So in case of overload and short circuit, current parameter increases beyond rated value. If beyond rated value current you pass through wires and through instrument, it will get damaged. So in this case, what is done? Circuit immediately made open by these fuses and circuit breaker. Okay, so this is rewirable or Kit Kat fuse. All of you can see, this is the one is base, another is cap. This one is the base. Okay, outer material is porcelain. For this is the cap. So for this also, this one is the porcelain. Okay, on the cap here, all of you can see, this is the fuse wire. See, from this end up to this end, it is fuse wire. They fix this fuse wire is made up of tin and lead alloy. So this fuse wire is fixed on this cap, and this cap you can fix to base. Okay, so what occurs in case of overload and short circuit? This fuse wire, it melts. This one fuse wire, in case of overload and short circuit, current become above rated value. So whatever the heat produced when current flows above rated value, that is enough to melt this wire. So this wire breaks, means circuit become open. Circuit becomes open means current in the circuit immediately becomes zero. So whatever the load and wires will be safe. Okay, so this is rewirable fuse or Kit Kat fuse it is called, because once this wire melt, you can first of all you have to make main switch off, then remove this cap, fix fuse wire to it, and then attach this or fix this cap to this base, and then switch on the main switch. But fuse wire must be there at home. Skilled person is required for this. So but its costing is less. Okay, so this is called as rewirable fuse or KitKat fuse. This is used for low current application. Okay, whenever it's a high current application like industries, institutes, so high rupturing capacity fuses are used. Okay, this one is rewirable. This is a semi-enclosed rewirable fuse. Earlier one is KitKat fuse. Okay, now this high rupturing capacity fuses. This one also high rupturing capacity fuses. So see this, what is it? It is used for higher current application. So this is compared to KitKat fuse. Okay, so this is the brass metallic ends. This outer body is made up of ceramic. Okay, now inside it from one end to another end, inside it from one end to another end, silver fuse wire is there. And whatever the rest space is filled with quartz powder. Now, in case of overload and short circuit, what will happen? This silver fuse wire, it melts. So the moment it melts, whatever the gases get produced, that reacts with that quartz powder, and high resistance material is formed inside it, which helps to quench the arc. Means if any fire is there inside it, that is called as arc. So it helps to quench it. Okay, to extinguish it. So this is high rupturing capacity fuses. But what is the disadvantage with this? It is expensive compared to KitKat and rewirable fuses. But once it operate, means once that silver wire melt, you have to throw it and you have to put another one. You have to purchase another one, new one. So costing increases. Nowadays, what is done? Whatever this rewirable fuses, KitKat fuse, which is its costing is very less, and this HRC fuses, this one you can't rewire, you have to purchase another one. So both this KitKat fuse, rewirable fuse, high rupturing capacity fuses, these are being replaced by MCB, miniature circuit breaker. Its installation cost is more. Miniature circuit breaker, MCB, its installation cost is more. But once you install it, you don't have to frequently rewire it. Even if it operates, you don't have to throw it, and you don't have to reinstall it. Okay, once it operates. Because what's with the HRC fuse? Once it operates, you have to replace it by another one. That is not the case with it. Just whatever it operates, means it trip off, means switch comes to off position. So you correct the fault and just manually you have to switch it on. Okay, so nowadays fuses and HRC fuses, rewirable fuse, are being replaced by miniature circuit breaker, that is MCB it is called. Okay, now we'll see about the MCB. Now see here, this is the live phase. Okay, and it can be with red color insulation, yellow color insulation, or blue color insulation. And this is the black one is neutral. Now, if you see first one MCB, it is called as single pole MCB, and it is there only in live phase. Okay, then this one is for phase also and for neutral also. So this is called as double pole MCB. If you observe the third one, it is for RYB. Okay, that's why it's a 3-pole MCB. And the fourth one is for RYB and neutral. So 4-pole MCB. Okay, so MCB as per requirement, you will find either single pole, double pole, triple pole, or 4-pole is used. Now we are going to see its construction, MCB. So miniature circuit breaker. See, if you from outside it looks like this. Okay, and now all these MCB, if you see, then they are, its position is on. This whatever the switch you can see, this one is at on position. If it is in the up position, means it is on. And whenever we say it trips off means what? Whatever the switch it comes to, it switches to down position. Okay, so what is the application of MCB? In previous experiment also I told you, in case of overload and short circuit, the switch automatically reaches to off position. Okay, we are going to see its construction, how it works. So first thing, it is acting as a switch. Whenever you wanted to switch on or off power supply, this switch manually you have to switch on and off. Means first thing is it is acting as a switch also. Second thing, in case of overload and short circuit, this switch, it automatically trip off. Means it makes circuit open. You have to correct fault then later on. And correct fault means what? If overload is there, minimize the load. If short circuit is there, see which one two current carrying wires are touching to each other. Insulate them properly, and then manually you have to switch this on. Okay, so three functions acting as a switch. In case of overload and short circuit, it gives protection. Okay, so inside it, when you open it, you will find like this construction inside it. Okay, so for this you will find, see, this one is bimetallic strip. Whatever this is bimetallic strip, and it gives, here it is written bimetallic strip. It gives protection in case of overload. Okay, and here this is the solenoid is there. Solenoid, all of you know, centrally it's a magnetic material, and round it one coil is wound. That is called as solenoid, electromagnet. Okay, this solenoid, see here it is written solenoid, it gives protection in case of short circuit. Okay, so if it's a overload, this bimetallic strip, because of it, this knob reaches to off position. If it's a short circuit, this is the assembly which works, because of which this knob reaches to off position. Okay, now here if you see at this end, this is called as fixed contact. This is called as fixed contact, this one written here. Okay, then there is some gap between fixed and movable contact. If there is a gap, means this knob is at off position. This is called as moving contact, that is dynamic contact, this one. Whenever you move this knob upward, what happens? This dynamic contact touches to this fixed contact. Okay, means lower one don't move, only upper one, this one. This one moves. Movable contact, it is called dynamic contact, it is called. When it moves, this knob is right now at off position, means there will be a gap between fixed and movable contact. So even if current is entering through this end, one wire is fixed over here, incoming wire, and leaving terminal is this one. Okay, outgoing terminal. See here it is written, it's the outgoing terminal, and this is incoming terminal. So whenever current enters over here, reaches over here, if gap is there between these two fixed and movable contact, then obviously, because this is off position, so current will not flow through further circuit. But whenever you switch it on, see here, whenever you switch it on, in this case you can find, see, whenever you switch it on, then see, movable contact is touching to fixed contact. Means current will come like this through this fixed contact, movable contact, through this solenoid, through this bimetallic strip, it moves to leaving terminal. And whenever the knob is at off position, there is a gap between fixed and movable contact. So on position, on off position, you can see here. Okay. See here, incoming current, fixed contact, movable contact through this solenoid, through bimetallic strip, and through leaving terminal. Like this is the flow of current when you switch on MCB. Now here, on position, off position, all of you can see same slides. This is the thermal unit. Thermal unit means what? Bimetallic strip. See, this one is bimetallic strip. It gives protection in case of overload. This is a solenoid. It gives protection in case of short circuit. See, inside it, this plunger is there and spring is also there. Because of this plunger and spring arrangement, that latch, it could make open in case of short circuit. Okay, see, in case of short circuit, current above rated value will pass through this coil. So whatever the magnetic field produced, that is sufficient to switch this plunger to, it pushes that plunger, and because of that spring plunger arrangement, latch, it opens and switch comes to off position. So fixed contact is there, movable contact is there. Okay, so see here, this one fixed and movable contact, this one. So whenever you continuously or whenever this switch you make on and off, this contact touches to each other and away from each other. So current, when two current carrying contacts touches to each other or move away from each other, there is a possibility arc will be there. Okay, so arc means like this, see, like this arc formation between two current carrying wires if they are touching to each other. So to extinguish this arc cutes are used. These are nothing but these are made up of copper. So like this you can find them. Okay, so this arc, see here it is, arc cutes. Okay, so what they do, whatever this arc produced, they spread that arc, and if you are spreading that arc means it will help to extinguish the arc formation. Okay, so this current carrying contacts, if they touches to each other or move away from each other, if arc formation is there, so this arc cute chambers are there, this helps to split that arc, and because of which it get extinguished. So this is the arc cute chamber. Okay. So this is about the MCB. In case of overload and short circuit, it makes circuit open. Okay, now we'll show you video for MCB, how it works. Now before it, we'll tell you about ELCB, earth leakage circuit breaker is also there. MCCB is there. MCCB means what? Molded case circuit breaker. So molded case circuit breaker, it is used for high current application. MCB is used for low current application. MCCB is used for high current application. Okay, so their purpose is same. In case of overload and short circuit, they make circuit open. Okay, molded case circuit breaker for high current application, miniature circuit breaker for low current application. Next to it is the ELCB, earth leakage circuit breaker. So if any leakage current get produced, so what happens then? In that case, RCCB if installed or ELCB is installed, then they operate. Okay, so RCCB means what? Residual current circuit breaker. So this one is RCCB, and ELCB is voltage operated. Okay, earlier one both were called ELCB, but later on they categorize them, distinguish between them. If it is current operated, then that is called as RCCB. Current operated means what? See here, trip coil is there. Trip coil. This trip coil means what? It is the trip coil means this one is a relay it is called. Okay, so what is happening? Whatever this live phase current flowing through it, same must be the current returning to neutral. So if any difference between the current flowing through phase and neutral, whatever the magnetic field flow through this core, what is it? See, this circular one, it's a magnetic material. Round it, phase coil is wound, neutral coil is wound, and they both are wound in opposite direction with each other. Whatever the flux produced by phase is in opposite direction with flux produced by neutral wire. So if both the currents are equal, they will produce equal flux, and both the fluxes in opposite direction with each other, resultant flux in the core will be zero, and this relay don't sense anything. But if there is a current difference, phase and neutral, so some flux will flow through this coil, and this relay sends the signal to RCCB. This is called as current operated. Okay, so RCCB you will find in electrical lab also. Suppose this is the load, it is not properly earth, or whatever the earth leakage current starts to flow through its outer metallic body, so neutral current will be less, relay will sense the fault, and RCCB operates. Okay, and if it is voltage operated, then that is called as ELCB. Okay, so RCCB and ELCB gives protection in case of earth leakage fault. Okay, only RCCB is current operated and ELCB is voltage operated. Okay. This is MCB. Okay, so this MCB, it's a 4-pole MCB. Once you open it, you can open it. So you will find it like this inside it. Okay, so this is one is fixed contact, this one is movable contact, solenoid, bimetallic strip, arc tube chambers, and living contact. Okay, so here, so see, this is latch, plunger spring arrangement is there inside it. Solenoid, in case of short circuit, it makes circuit open. That switch comes to off position. Okay, see, this is the bimetallic strip, this one. In case of overload, it gives protection. So now switch is off because these two are touching to each other. So switch is in off position. Okay, so see, now if you push this plunger, so through that latch, see, it trips off. This latch works and it trips off. See, again you watch. In case of short circuit, it occurs like this. See, there is a gap between fixed and movable contact. Now it is closed one. If you pushes it, that through that latch, these two contacts become open. Okay, so this is the short circuit. And in case of overload also, you observe here, this is the bimetallic strip. See, if that bimetallic strip, in case of overload, it bends. So see, like this switch becomes open. Okay, so here what is the this is the solenoid. This solenoid, in case of short circuit, whatever the magnetic field produced by it pushes that plunger so that these two contacts become open. See, now it's showing now. See, these two are connected. Consider short circuit is there. So whatever the magnetic field produced by this solenoid, it will push this plunger so that this latch causes this switch to off position. See, now they are showing it in case of short circuit. See now, in case of short circuit like this. So these two contacts become open. This is the short circuit. And overload means, see, this is the bimetallic strip. In case of overload, whatever the current flowing, it causes this strip to bend. And it bends so that this latch causes this open. See, now they are explaining the overload case. See, like this occurs in case of overload. Okay, so